SQA High Maths 2015, paper 1, question 1 on vectors. Vectors u and v are perpendicular. Find the value of t. Right, if two vectors are perpendicular, it means the angle between them is 90. And cos of 90 is 0. So u dot v equals 0. So perpendicular means u dot v equals 0. So let's work out u dot v. Start of the exam paper tells you just times each of the components together. So you do 8 times the i's together plus the j's together plus the k's together times. So u dot v is equal to 8 times minus 3 plus 2 times t plus minus 1 times minus 6. And we know that's going to equal 0. So 8 threes, that's minus 24 plus 2t plus 6 equals 0. Minus 24 plus 6 is minus 18 plus 2t equals 0. So 2t must be 18. Moving it over, so t equals 9. And we're done there. A tangent to a curve. SQA High Maths 2015, paper 1, question 2. Find the equation of a tangent to the curve y equals 2x cubed plus 3 at the point x equals minus 2. Equation of a tangent means differentiate and sub in the number. So step 1, the y by dx. 3 times 2 is 6x squared. So at x equal to minus 2, the y by dx equals 6 times minus 2 squared. 6 times 4, which equals 24. So the y by dx is 24, which remember is equal to our gradient m. When x is minus 2, y equals 2 times minus 2 cubed plus 3. That's 2 times minus 8, add 3. Minus 16 plus 3 is minus 13. So our point is minus 2 minus 13 and our gradient is 24. So that means that y plus 13 equals 24 x plus 2. Y plus 13 is 24x plus 48. Or y equals 24x plus 48 minus 13 is 35. And we're done there. Okay, looking at factors and remainders. SQA Higher Maths 2015, paper 1, question 3. Show that x plus 3 is a factor of this polynomial and hence factorise fully. A couple of ways you can do this, but the most common way is synthetic division. So looking at synthetic division, you take your coefficients of these. So I've got 1x cubed minus 3x squared minus 10x and plus 24 on the end. And I'm subbing in x plus 3, so I'm subbing in minus 3 because minus 3 is the root. So we drop 1 down. 1 times minus 3 is minus 3. Minus 3 plus minus 3 is minus 6. Minus 6 times minus 3 is 18. 18 take away 10 is 8. 8 times minus 3 is minus 24. And 24 take away 24 is 0. So I can just write a little statement. Since the remainder equals 0, x plus 3 is a factor. And we're done there. Now we need to factorise fully. So we've all done most of the work. We know that x plus 3 is a factor. So we've got x plus 3. And then we've got x squared minus 6x add 8. X squared minus 6x plus 8. So that's x plus 3, and then from National 5, this is just a double bracket. Two numbers at times together to make 8, but add to make 6 is 4 and 2. I want minus 6 in the middle, so it's minus 4, minus 2, and that's it factorised fully for final answer. Of related functions, SQA High Maths 2015, paper 1, question 4. The diagram shows the graph of a function y equals p cos qx plus r. So it's a trig graph. Write down the values of p, q, and r. Okay, so we need to start off with what this function is. The normal cos graph, if you remember, goes between 1 and minus 1, like so, and it goes up to 2 pi. So the number in front is called the amplitude, then the period of the frequency, and then how far it's moved up or down. So immediately we can see that if we look at the q first, we've got 1 up to pi over 2. Which means if I was to keep drawing that, I would have 4 up to 2 pi, because pi over 2 is 90 anyway. So I can immediately write down that q equals 4, because I should have 4 of them up to 2 pi. Okay, to get our amplitude, if we just work out the difference between the maximum and minimum, I've got 4 and minus 2 is 6. So to get p, I can just do 4 to minus 2 is 6. Half of that is 3, so I get 3. P is 3. And then for r, well, now I've got p, it's easy. If it was just 3 cos x, it would go up to 3, but it starts at 4, so I've added 1. So r is just equal to 1. And we're done there. We'll write down the values of p, q, and r. Now, what the function is? 3 cos 4x plus 1. Inverse functions. SQA Higher Maths 2015, paper 1, question 5. A function g is defined on the real set of numbers by g of x is 6 minus 2x. Determine the inverse function for g. So for part A, there's a few ways you can do this, but I'll write it out the way I do it. 6 minus 2x. I'll just let's say that's y equals 6 minus 2x. And I'll rearrange that to make x a subject. That means taking 2x over to the left. 2x equals 6 minus y, taking the y over to the right. So x is 6 minus y over 2. Splitting that up, that gives me 6 over 2 is 3 minus a half of y. And therefore we can write the inverse function of x is simply 3 minus a half x, or you might prefer the inverse function of x, writing the x first is minus a half x plus 3. Part B, write down an expression for g of the inverse function of x. Well, you should already know that g of the inverse function of x should be x, but let's say you didn't know that, let's do the work for it. So part B, g of the inverse function of x is equal to, well, that's g of minus a half x plus 3. That equals, remember, g was 6 minus 2x, so 6 minus 2 times minus a half x plus 3. That gives me 6. Minus 2 times minus a half is plus 1x. Minus 2 times 3 is minus 6. 6 minus 6 is 0, so we get x, and there we are. Okay, evaluate numerical expressions. SQA Higher Maths 2015, paper 1, question 6. Evaluate log 6 12 plus a third of log 6 27. So I'll keep the log 6 12 to start with, but then I'll write that as plus of log 6 27 to the power of 1/3, because we can take that up. So that's log 6 12 plus 27 to the power of 1/3 is the cube root of 27, which is 3. So log 6 3. And then adding logs means we can just turn it into one log and the numbers times together. So that's log 6 of 12 times 3. That's log 6 36, which is equal to 2. And that's because, remember, 6 squared equals 36. So 2 is our final answer, and we're done there. SQA Higher Maths 2015, paper 1, question 7 on differentiating a polynomial. A function f is defined on a simple domain by f of x is root x, 3x minus 2 over x root x. Find f dash 4. So we need to get it ready to differentiate. So f of x is equal to root x is x to the half, 3x minus 2 over x times x to the half. So we need to get that all tidied up first. So that is x to the half times 3x minus 2 over x to the 3 halves. And then we can multiply our brackets out to get 3x to the 3 halves minus 2x to the half over x to the 3 halves. And tidying that up even further, f of x is 3x to the 3 halves minus 2x to the minus 1, a half minus 3 halves. Now we can differentiate it, f dash x, take the power down to the front, so it's 3 halves times 3, x to the, take 1 away from the power, so it's a half, minus times a minus is a plus, so plus 2x to the minus 2. Tidying that back up because it was a non-calculator question, so we can substitute 4 in. We get f dash x is equal to 3 3s are 9 over 2 root x, x to the half, plus 2 over x squared. So now we need to substitute 4 in. So f dash 4 is equal to 9 over 2 root 4 plus 2 over 4 squared. That's 9 over 2 times 2 plus 2 over 16. That's just 9 plus an eighth. So we can just write 9 and an eighth if we want as our final answer. Okay, looking at quadratic inequalities, SQA Higher Maths 2015, Paper 1, Question 8. ABCD is a rectangle with lengths x and x minus 2 as shown. If the area is less than 15, determine the range of values of x. Well, area is length times height. So I'll just write that down, or length times breadth if you prefer. So our length is x, and that's x minus 2. And it says that that area has to be less than 15. So I'll just write x minus 2 is less than 15 to set up my inequality. Expanding my brackets, I get x squared minus 2x is less than 15. I've got a quadratic, so I need to take the 15 to the other side. And we need to then find out the roots and draw a graph to see where it's less than 0. So looking at the roots of this, we've got x squared minus 2x minus 15. If that's factorizable, hopefully, we get x and x, 5 and 3. Minus 5 plus 3 is minus 2, so roots are x equal to minus 3 or x equal to 5. So that means we can draw a quick sketch at the side. Minus 3 is over here, and 5 is over here somewhere. It's positive x squared, so our quadratic looks something like that, and it just has to be a quick sketch. Now we're looking to see where it's less than 0. Well, it's less than 0 below the x-axis, so that is in between these two numbers. Minus 3 is less than x is less than 5. But we need to be careful with this question because it is about the area of a rectangle, so we can't have a negative length. X must be, let's have a look. We've got x minus 2 is our smallest, so it has to be bigger than 2. Or the breadth would be negative. And therefore, our actual answer is 2 is less than x is less than 5. Need to be very careful with ones where it's in context. SQA Higher Maths 2015, Paper 1, Question 9. ABC are points such that AB is parallel to the line with equation y plus root 3x equals 0, and BC makes an angle of 150 degrees with the positive direction of the x-axis. Are they collinear? So you need to know what collinear means. They are all in a straight line. So if you work out if A to B are parallel and B to C are parallel, and when it says B is a point in common, they would be in a straight line because they're parallel or not. So let's just work on this. So the first part is to work out the gradient of AB. So for A to B, we have got y equals minus root 3x. So the gradient of that section is just minus root 3. For B to C, well, gradient equals tan theta because we've got the angle 150 degrees. So our gradient is equal to the tan of 150. Now, 150 is going to be an exact value. If you've got a cast diagram, we can see it's related to 180 minus 150. So if I work out the tan of 30 degrees is 1 over root 3. But 30 degrees is positive here and here. So that's 180 plus 30, which is 210. And that's 180 minus 30, which is 150. Here, tan is negative, so the tan of 150 is minus 1 over root 3. And then we can just make a little statement. Since the gradient of AB doesn't equal the gradient of BC, the points are not parallel. and so they're not collinear. Not parallel, so not collinear. Now, if they were equal, you would then say they are parallel, but since B is a common point, they're collinear. Maths 2015, paper 1, question 10, addition and double angle formulae. Given that tan 2x is 3/4, part A, find cos 2x. Right, okay, so part A, we know tan 2x is equal to 3/4. So that means we can draw a right angle triangle, and we could call this angle 2x. And opposite is 3 and adjacent is 4. By Pythagoras, 3 squared plus 4 squared is 5 squared. This is a standard Pythagorean triple. So we can immediately write down cos 2x because that is adjacent of hypotenuse, which is 4/5. So a simple 1 mark question there. Part B, we have to work out cos x. Well, we can't go from cos 2x to cos x directly. Don't be tempted to divide by 2. We need to expand cos 2x. So there's the start of the exam paper. There's a number of trigonometric identities. Pick the one you want. 2 cos squared x minus 1 would work. So I'm going to pick 2 cos squared x minus 1. And cos squared x is the same as cos x squared, remember. So we know cos 2x is 4/5, so we've set up an equation basically, because that equals 4/5. So that means that I can add 1 to both sides to get 2 cos squared x. Well, if I add 1, it's the same as adding 5/5, so 5 and 4 is 9. That gives me 9/5. So cos squared x dividing through by 2 is 9/10. And therefore cos x is the square root of 9/10. So I can write that down. Cos x is the square root of 9/10. Well, from the rules of surds, I can split that up into 2 square roots, the square root of 9 over the square root of 10. So that's 3/√10. Square root of 9 is 3, and root 10 is already a simplified surd. And we'll just define the exact value of cos x, so we've done that, so we're done there. Okay, SQA Higher Maths 2015, paper 1, question 11. T minus 2 minus 5 lies on the circumference of the circle with this equation. Find the equation of the tangent to the circle passing through T. So let's work out the equation of the tangent. If we draw a little picture, just to give us an idea of what's happening, let's say that T is here, and we'll call that minus 2 minus 5. And this is not an accurate picture. Then we've got our centre of our circle where we can work out our centre. It's minus 8 minus 2. And we have to find the equation of a tangent passing through T. So a tangent makes a radius at right angles. From National 5. So if we work out the gradient between the centre and T, then m1 times m2 equals minus 1. So the gradient, I'll just call this the centre C, between C and T, equals minus 5 minus minus 2 over minus 2 minus minus 8. That's minus 5 add 2 is minus 3. Minus 2 add 8 is 6. So that's minus a half. So therefore the gradient of our perpendicular equals 2, since m1 times m2 equals minus 1. So we've got our gradient of 2, and then we can use our point. So y minus b equals mx minus a as usual. The point obviously we're using is t. So it's y plus 5 minus minus 5 equals 2x plus 2. Multiplying that out, we get y plus 5 is 2x plus 4. So y equals 2x minus 1 is the equation of our tangent. B says the tangent is also a tangent to a parabola with equation y equals minus 2x squared plus px plus 1 minus p. Determine the value of p. So we've got y equals 2x minus 1, and then for part B, we've also got y equals minus 2x squared plus px plus 1 minus p. And since this is a tangent to this, then these are equal to each other. We can solve them simultaneously. So all we need to do is say that 2x minus 1 equals minus 2x squared plus px plus 1 minus p. So that's a quadratic to solve. So moving everything over to the same side, or just move everything over to the right, we get 2x squared plus 2x minus px, then minus 1, then minus 1 again, and then plus p, and that equals 0. Tidying that up, squared, and then we want to have x as a thing, so that is plus 2 minus p times x, and then we've got as a constant term minus 2 plus p equals 0. Now if it's a tangent, b squared minus 4ac equals 0, because it only has one solution. So that means we can say, remember, that would be our A, this would be our B, and this whole thing here would be our C. So we can say that we've got 2 minus P all squared minus 4 times 2 times minus 2 plus P equals 0. Solving that, multiplying out the bracket, we get 2 2's is 4 minus 4P plus P squared. And then we've got minus 8 times minus 2 is plus 16. And then we've got minus 8 times p, so minus 8p equals 0. Continuing on to solve this then, we've got p squared minus 12p plus 20 equals 0. So another quadratic to solve, but this one should be factorizable, hopefully. Double brackets. We've got p and p. 10 and 2 make 12 when you add them, so it's 10 and 2 minus 10 minus 2. So p equals 2 or p equals 10. But then if we go back to the original question, it says p is greater than 3. So we're disregarding this one. P equals 10 as our final answer. Higher Maths 2015, paper 1, question 12. Some unusual integration questions or some harder ones. So the diagram shows the graph of y equals a cos bx. The shaded area is a half. So we know that this is a half. What is the value between 0 and 3 pi over 4? This is checking if you understand graphs and also understand the symmetry in a sine graph. So if we know that that's a half, if I draw a little line here, we know that that's also a half, and therefore that bit must also be a half. But it would be minus a half and minus a half because we're below the x-axis. So that means that our integral between 0 and 3 pi over 4 of a cos bx just simply must equal, well, we know that's a half as well, just to be clear, it must equal 1/2 minus a half minus a half. So a half minus a half 0, minus another half is minus a half square units. And that's it, we're done there. Logarithmic graphs, SQ High Maths 2015, paper 1, question 13. The function f of x is 2 to the x plus 3 is defined on R, the set of real numbers. The graph of equation y equals f of x passes through 1b and cuts the y-axis at q as shown. What is the value of b? Well, it passes through 1b, so I can just sub 1 in. So for part A, we've got f of x is equal to 2 to the x plus 3. So at x equal to 1, we're going to say that f of x equals 2 to the power of 1 plus 3, which is 2 plus 3, which is 5. So just to answer the question, b equals 5. And we're done there. Part B says copy the diagram above, inspect the inverse function, and then write down the coordinates of the images of P and Q. What it means by the images of P and Q is what does P and Q become in the inverse function. So this is an exponential, so the inverse function is a log. So we need to reflect that in the line y equals x. So let's just go ahead and do that. So I've copied the diagram below. So we already know that P is 1b, which we've just worked out is 1, 5. And then let's work out our y-intercept for this graph. So that is when x equals 0. So f of x, which was 2 to the power of x plus 3. That's 2 to the power of 0 plus 3. 1 plus 3 is 4. So we get 0, 4. We need to reflect in the line y equals x. So drawing a y equals x sign. So 0, 4 becomes along 4, 0. And 1, 5 becomes 5, 1. And we've got an exponential curve like so. That's the inverse function of x. So that's part 1 done. And then for part 2, I've already done the work for it. The image of P and Q, we've got 4, 0. And we've got 5, 1. And we're done there. Part C says, R3, 11 lies on the graph of equation y equals f of x. Find the coordinates of the image of R on the graph of equation y equals 4 minus f of x plus 1. So writing down f of x again, f of x, remember, was 2 to the power of x plus 3. And we know that the r lies on this, which is 3, 11. So our new equation is y equals 4 minus f of x plus 1. So what does that mean? Well, let's just take a few notes. In here means we move left by 1. Minus f of x means we reflect in the x-axis. And you can think of this, that's like plus 4, so move up by 4. If it helps, you can rewrite this as minus f of x plus 1, and then add the 4 in the end, and you might be able to see that better. So that means we've got our r, which was 3, 11. So doing the things in the correct order, we apply our reflection, and then we move the left, and then we move up. So our reflection minus f of x plus 1, 3, 11 becomes 3 minus 11, because it drops down underneath. And then that goes to moving left by 1, so 3 becomes 2, so 2 minus 11. And then finally, we need to move up by 4, so we get 2 minus 7 as our final answer. Now, if you're really struggling with that, one way to do it is to go back to the original graph and actually draw it, reflect it, move it to the left, move it up, and note that point moving around. Okay, some unusual circle questions. 2015, paper 1, question 14. A circle with this equation meets the coordinate axis exactly 3 points. What is the value of k? So drawing a quick sketch of this, we've got 2g is minus 12 and 2f is minus 10. So g is equal to minus 6 and f is equal to minus 5. So our centre is equal to 6, 5. So along 6 up 5 somewhere is the centre of our circle. Touches the coordinate axes at exactly 3 points. So it could, if this is the centre here, it could touch here, but then it would have to touch at this point to come back up here. So if we draw a picture of that, we get something like this. That would be one option. And this is just a wee quick sketch to get an idea of what's happening. But also, we could have the y-axis be a tangent. So we could also alternatively have something like this is a tangent, but then it dips under. And this is a 0.65. So that's our 2 options for this question. So we'll just look at option 1 and option 2. So let's look at option 1. So let's look at the radius. We know it as 0, 0. So the radius of this is just going to be 6 minus 0 squared, which is 6 squared, plus 5 minus 0 squared, which is 5 squared. 6 sixes is 36, plus 25. That's just the square root of 6 to 1. So in option 1, we just get the square root of 6 to 1. So we know our radius is the square root of 6 to 1. But from the equation, g squared plus f squared minus c equals the radius. So we know that g and f is 6 and 5, but we've got c as k. So from the equation, we also get our radius is equal to the square root of 6 squared plus 5 squared minus k, because c is k. That is the square root of 61 minus k, and therefore k must be 0. That should be pretty obvious. So for option 1, k is 0. Now let's look at option 2. So in option 2, from the equation, our radius will still equal the square root of 61 minus k, but if we've got some points here, so this is along 6, so we know that that's the point 0, 6. Our radius is 6 in other words, so we know that the square root of 61 minus k must equal 6. Square on both sides, we get 61 minus k equals 36. So that means that k equals 61 minus 36, which is 25. So there's our two options for k. K could be 25 or k could be 0, depending on what exactly is happening in this question. Differential equations, SQA Higher Maths 2015, paper 1, question 15. The rate of change of a mug of coffee is given by this differential equation. It tells you some information. Express t in terms of t. What you need to realise is if you integrate a dt by dt, you just get t back. So we can just immediately say that t equals the integral of the right hand side, 1 over 25 t minus k. And that will be with respect to t, because it's dt instead of dx as normal. So we'll just integrate and let's go. So we get 1 over 25 t squared, and then we times by a half because we divide by 2, and then minus k times t, but then we've also got plus c. So there is our integral. Let's just tidy that up. Dividing by a half, we get 1 over 50 t squared minus kt plus c. So there's our initial step, but then we need to eliminate that c, but luckily we're given some information. It says initially the temperature of the coffee is 100 degrees, 10 minutes later the temperature has fallen to 82 degrees. Express t in terms of t. So first step, we know that initially when t is 0, the temperature is 100. So we can say that when t equals 0, big T equals 100. Subbing all that in, we get 100 equals 0 minus 0 plus c. In other words, c equals 100. So we've now got t equals 1/50th of t squared minus kt plus 100. But we need to find this k, so we've got an extra bit of information. 10 minutes later, the temperature is 82. So in other words, when t equals 10, big T equals 82. Subbing that point in, we get 82 equals 1/50th of 10 squared minus k times 10 plus 100. So we just need to solve and get k back out. 82 equals 100 over 50 minus 10k plus 100. Just quickly running through this, you get 2 minus 10k plus 100. So you get 82 is 102 minus 10k. Moving the 10k over to this side to make it positive. That is 102 minus 82 is 20. So k is 20 over 10, which is 2. So our final answer is just t is equal to 1/50th of t squared minus 2t, because k is 2, then plus 100. And we're done there.